Okay, so what we're going to do is start with a workbook check for the first part of class. While the workbook check's going on, I want you to work on this. And so go slow, don't rush through it. When you're explaining the meanings, we want all the details, all the specifics. So just to say time, or just to say angle, or just to say distance is not nearly enough. So we want all the details on every one of those expressions. Okay? And then there's a couple more questions down here. Definitely, at least when you're done, compare with someone next to you if you're not, or work together on it. And then when you feel good about what you got, then you can start on page 288, worksheet 6, and just start working on that and get as far as you can before we regroup. Okay? So you got plenty to do. And I'm going to call you up. I'm going to call you up by first name today, and just bring your workbook, and we'll do a workbook check. Okay. So this is the water. This is what you worked on. The water wheel makes a full rotation every 13 seconds. The radius of the wheel is 7.5 feet. The bottom of the wheel is 2 feet above the surface of the water. A point on the wheel starts at the 3 o'clock position and turns counterclockwise. First one is to write a function f. Okay. So the first one is to write a function f. And so we need to know what the output is and what the input is to write that function. So how about what's the input? Input is time for number 1. Is that right? Agree with that? So as a function of angle swept. So what symbol do we want to use? Theta is common. We could use any angle. Usually Greek letters are usually our angles. Okay? And so output, vertical height of the point in radius lengths above the horizontal diameter. So sine is vertical height. And our input there is theta. So is that it? Do we need to add something or multiply by something? So
don't you divide theta by the radius?
Divide theta by the radius. What goes into sine? So what quantity does sine receive? What kind of thing? Angle, right? And that's what we got. Yeah, so we don't want to divide it by anything because the input is angle, and that's what goes into sine. Okay? And so does this give us radius lengths above horizontal diameter? Yeah, that's it. That's what sine is. That's exactly what just the plain old sine function is. So the way I'm defining it here is just exactly what sine is. So we're done. Okay? G, what's the input into G? Still theta. But what's the output now? What's different? What's different now? It's in feet instead of radius lengths. In feet instead of radius lengths. So if the radius is 7.5 feet, okay, a little distracting. It's a little distracting there in the middle. If it's for me, it's especially distracting for people around you. Okay? So 7.5 feet is the radius. If this is number of radius lengths, then how do we get that same value in feet? Yeah, doesn't it make sense? If you have the number of radius lengths and you multiply it by the length of one radius, it's going to give you the total number of feet that you are. In this case, vertical distance. Does it make sense? Okay? Next, write a function that gives h, that gives the vertical height in feet as a function of time elapsed. So our input now is time. Now we still want a vertical height in feet, and that's what multiplying the radius times sine does. It gives us a vertical height in feet. The question is, what goes into sine? This is called the argument, the thing that goes into sine as a whole, or it goes into cosine. It's called the argument. And so, if our function is if our input is t, then that argument is going to be an expression that has t in it. Okay, so this is where this comes in. A water wheel makes a full rotation every 13 seconds. So the question is, what expression of t here is going to ensure us that when t hits 13, we make a full cycle or a period of sine values?
B13.
Okay, so here's kind of one way to think about that. It's going to be some number b that we don't know times t. So the question is, what is that b value? What is that b value such that if the time was 13, what would the argument need to be when the time is 13? Okay, what about 1? Agree with that? What does bt equal? What kind of thing is it? What is the argument for sine?
Would it equal 2 pi? 'Cause that's
Okay.
the rotation.
Yeah, so what kind of quantity is that? What kind of quantity goes into sine? Yeah, so what goes into sine is always angle. So the argument for sine is always angle. And so what do we want? We want that when the time hits 13, what angle will give us a full rotation? 2 pi. So those need to correspond. 13 seconds needs to correspond with 2 pi, so that when 13 seconds hits, we're actually putting 2 pi into that, because that would be our full rotation for sine. Make sense? So to get our function, we're solving for b. So b times 13 is 2 pi. And so the value of b is?
0.4833.
Oh, we'll write it exactly as 2 pi over 13. But yeah, so yeah, that's a decimal approximation. That's fine. So we just solved for this coefficient that we need that ensures us when t hits 13, what goes into sine hits 2 pi. Because that's what we need to make sure that period is 13. Okay, and so you had a decimal approximation for that?
Yeah, it was 0.433219467.
0.4.
Yeah, that works.
0.43. Okay, so now the last one is our function j. So the input is still time, and now the output, now we bring the water into it, and we're saying we want the output to give us the vertical height of the point in feet above the surface of the water. Above the surface of the water. So remember, the bottom of the water is 2 feet. The bottom of the wheel is 2 feet above the surface of the water. So how are we going to write this function?
We take the existing h is that 2 here.
Okay, so he wants to take this function here. Which gives us vertical height in feet, and now add 2. What do we think? All right, well let's try that. Okay, so let's graph that and see if what we see in the graph makes sense. So I've got that here, so we want to take this one here and add 2, is that right? So let's graph that. Okay, now let's remember what are our two quantities. So our input is what kind of, our x value or the input is what? What does that refer to? He said time or angle? Which? X.
It's time,
But
the
it's-
entire thing in the parentheses is the angle.
Right, exactly. So what goes into sine is angle. But this is a function of time. This is our input variable is time. So our x coordinate is time elapsed since 3 o'clock position. Okay, what about our y coordinate? So what is this output? What's our goal for that output to represent? What were we going for when we wrote this function? What's that? Okay, distance of the point above the water. All right, so now we look at our graph. We imagine what's going on here. We got a nice little blue water here, right? And we know that the wheel is something like this. Well, that's not great. Too close. Okay, and I think according to the instructions, this was 2 feet. Is that right? And then here is our horizontal diameter. Okay, so how did we do with this function? Does it give us the distance of the point above the water? Yes or no?
No.
I got 2 no's. More no's. More no's. Why no? What's wrong? It's going, so yeah, so if this is distance above the water, then what does the x-axis represent? That's the water, right? Exactly. So at 0, this is the water. So this is showing the lowest point of the wheel is negative 5.5, or underwater. Underwater, 5.5 feet. So what happened? What did we do wrong? So again, what is this quantity without the plus 2? Distance from where to where? Vertical distance from the horizontal diameter, right? So if I throw a point up here like this, it's this distance right here. So what's the maximum distance above the water that should get to? So what is the maximum distance above the water that should get to? 9.5?
No, it should be 19.
19? So what's our radius? 7.5. So there's a radius, and then there's 17 feet. Right? 2 radius, and then the 2 feet. So it should be going up to 17, and down as low as 2. So this function should be a max of 17 and a minimum of 2. So how do we get that? How do we get that right? What's that? No, if y is the distance above the water, distance of the point above the water, then it is. That's the water. Our function is wrong. It's not the axis that's wrong. Our function is wrong. Do you see? If our y quantity is distance, if the output we want to be distance of point above the water, then positive means above and negative means below the water. And so 0 is the water. So how about this? How high is the horizontal diameter above the water? 9.5, right? A radius plus 2. So we got 2, and we got 9.5, and we got 17. How much do we want to move this function up to get it right? Because it's going to go above the horizontal diameter, it's going to go up 7.5 above the horizontal diameter and 7.5 below. That's what this function is going to do. So where does that horizontal diameter need to be so that the bottom is at 2? At 9.5, right? So we can't just add 2. We've got to move that horizontal diameter all the way up to 9.5, or a radius plus 2 above the water, so that the minimum's 2 and the maximum's 17. Does it make sense? Adding 2 doesn't work. A picture tells 1,000 words. We got to get that horizontal diameter up to the right distance above the water, which is 9.5 feet. Okay, now what about now? Did it work? So what's our minimum? 2, right? Minimum 2, maximum 17. Where's the midline? Right there, 9.5. Is one cycle in the right place? So one cycle is how many seconds? How many? Yeah, that was our period. It takes 1. So this is the period. 13 seconds for the output to do a full cycle, right? So it's the length of the interval of input for the output to make one full cycle of output values. So it looks like we got it right. Questions on this example for your homework today? Does it all make sense? So the bits in, so we built this function by building one function at a time to get there. And so the reason we did that is so that you really understand what all the pieces are doing, right? What is x? What is the argument? What is sine of the argument? What is 7.5? And then how do we add so we get it to the right height? So all those things are really important. Any questions before I erase this? We good? Okay, how about this new problem that I gave you at the beginning of class? So now we got a fan, and we got this function 28 cosine 3t. So we want to describe each quantity. So t, what is t? So we probably need to start by saying this is about for a point on the fan. We had to have a specific point on the fan. Okay, so t. What did you think t meant? Time in seconds since the fan was turned on. Do we need anything else? We want to make sure we got all the specifics. Do we need anything else for that? What about that? So let's focus on the point. So since the point began to rotate from 3 o'clock counterclockwise. If it doesn't start at 3 o'clock and it doesn't rotate counterclockwise, the cosine function doesn't apply. Cosine function has that built into its meaning. You need to start at that 3 o'clock position and go counterclockwise for your angle. Okay? So what about, so that's the time in seconds. What about 3t? Okay, what angle? Again, angle is not specific enough. So 3t, first of all, is 3t an angle? You agree? It's an angle? Which angle is it? Angle swept Counterclockwise from 3 o'clock. So, so it's an angle that the point sweeps counterclockwise from 3 o'clock. Okay, and we can say radians. Radians is convenient because it helps us to tie into arc length easily. But it could be, that could be degrees too. All right, but we're going to say radians. And so I really should have put another one in here. What does the 3 represent? What about the 3? So let's talk about what is that number 3. So if t is the time in seconds and 3t is the angle, then how does the 3 come into that? What's that? Number of radians. So the point goes 3 radians. The number of Okay, you're on the right track. So maybe we can, so if you're ever not sure of things like this, it's really helpful to build a table. So we said that 3t is the angle, right? So if t is 1, how many radians has this fan rotated? Right, yeah. If t is 1, then the angle swept is 3. And if t is 4, 12, and 10. So the fan speed has been offered up. So the number 3 is some number we multiply by t to get the number of radians. So is it the speed of the fan? So for every second that goes by, how many radians does it turn? For every second it turns 3. So in 10 seconds it turns 30. In 5 seconds it turns 15 radians. So yeah, this is the fan speed in radians per second. Okay, so then how about cosine of 3t? So now we're going to take that angle swept in t seconds, and we're going to put it into cosine. And what will that give us relative to the fan scenario?
Distance to the right or diameter.
He wants distance, horizontal distance, right of vertical diameter in radius lengths. I thought it was in inches. Yeah, the cosine doesn't know what the units of your circle is. It spits out radius length. It spits out radius length. So then what is 28? So it's radius. So if we're talking about, if we're focusing on this point, what does that 28 mean? That 28 number of inches. Being swept out, is it arc length, 28?
Isn't that from the origin?
Yeah, so it's number of inches from the center of the fan to the point, right? So it's a radius, but in terms of that point, so it's that radius out to the point from the center of the fan. Okay, so then what is the 28? Cosine 3t is the number of radius lengths to the right. What does it mean to multiply that by then the length of the radius? What do we get?
The horizontal distance to the right, vertical diameter in inches.
Well said. Okay, that's what it is. So if cosine is in radius lengths and we multiply it by the length of a radius, then we're going to get it in the units of the radius. So now we're in inches. Okay, input. So which of these is input? You said t. Agree with that? T is the input. right? F of t, right? T goes into this function. What's the output of this function? In, it's the last one, right? That's our output. Our output is horizontal distance to the right in inches. What's the argument? Argument refers to the whole expression, the whole thing that goes into cosine or sine. Yes, exactly. Right, because what goes into cosine or sine, it always thinks it's an angle. So that argument will always be angle. That's right. Okay, questions about that? So just as a quick follow-up exercise here. Any questions on those? So as a follow-up exercise here, take a look at this. This one that I've bolded here. So that in blue. For the same fan, what could be the meaning of the function? This is the same fan now. 12 cosine 6t minus 55. So just take a minute and see what you can come up with. It's the same fan now. It's the same fan, but a different function. What could be the meaning of that function? So talk to the person next to you and see what you can come up with in terms of what the meaning of that function would be. Go. Okay? That's the right question. Yeah. Okay, half the people in the room should be talking. Find someone to talk to. Go. How are we doing on passing homework? Are there any extras? That's the second best fan I've drawn all day today. And it's also the worst one I've drawn all day. Okay, so before we said that point, I'll make it red. So here's that point. Before, where was that point at? It started at 3 o'clock, but what else did we know about that point on the fan? This is going to a question about how can it be 12? That's right. Initially, this was 28 inches. So how can this function have 12? What is? Wasn't it? Isn't?
Yeah, whatever point we want to call it.
The new one? Yeah, the new point would be where? Where? Exactly where is it? 12 inches, right? 12 inches away from the center. So now we're referencing another point that's closer in on the fan blade so that it's 12 inches away from the center rather than 28. Okay, what about the 6t? What about the 6? In 1 second, now how many radians does it cover? 6. So it's faster speed, twice as fast. How much does it rotate in 1 second? But what is that? So like, how would you explain that to somebody? He said almost a full revolution. What's a full revolution? About 6.2 2/8, right? 6.28. 2 times 3.14. So yeah, it's almost making it all the way around in 1 second, the new speed. Okay, here's the hard part. Anyone come up with what could this minus 55 mean? What's that? Hanging off of a ceiling? Okay, that's good start. But what does cosine mean? Remember, what is cosine? What is this tracking? Horizontal distance. So does it have to do with up and down? No, it has to do with horizontal distance. So if we're tracking the horizontal distance of this point, what would it mean to, we were always subtracting 55 from its horizontal distance from the center. What's that?
Move the fan over 55 inches?
Which way? Left or right?
Or left.
Left, into negative territory, and then we're referencing that point from where? Yeah, some wall, right? So it's like the distance to the center, to the vertical diameter is 55 inches, and we got a wall like this. What is 55 inches away from the wall? The point? Remember, cosine is the distance from what?
Oh, from the vertical.
From the vertical diameter. So as time goes by, from the vertical diameter, it's going to be positive, negative, as far as 12 inches, right? And then we're going to subtract 55. So that the reference, this is just like the moving the water wheel up. We didn't move it up 2. How much did we move it up? We move up that center line. So that is always the distance of the center line. Right? So this is how far to the vertical diameter. The 55?
Yeah. Because we didn't reference the wall.
What's that?
It's like wall wasn't referenced earlier, so
I was saying, what could this function mean?
Oh.
What could this function mean? So it was like, what could it be? So if it's minus 55, then it's the distance of that point from some location 55 inches over to the right. So now we're always in negative territory. What's the closest that the fan gets to the wall? Or that point? So what's the closest that it gets? Yeah, it'd be our 12, positive 12, minus 55. What's the furthest that it gets from the wall? Yeah, it'd be the minus 12, minus 55. 67. Minus 67. Make sense? So the biggest that 12 cosine can be is positive 12 when it's in the 3 o'clock position. And then we subtract 55 and it's 43 inches from the wall. The smallest 12 cosine could be is negative 12 when it's in the 9 o'clock position. And so now it's 67 inches from the wall. Okay, any questions? Okay, get top hat ready. Two questions.